Hello problem solvers. So here is a geometry question. You have a cyclic quadrilateral and whose diagonals are perpendicular. So CE and DF are perpendicular. Prove that the broken line CAE, so the center is A. The line CAE divides this cyclic quadrilateral into two parts with equal area. Okay, that's what we want to prove. Please give it a try. If you have experience playing with the mathematical competition, you know that this usually is not a hard geometry question. Do you know why? Well, because I haven't encountered a difficult question who asks me to prove something about the area. Okay, the hardest geometry question asks you to prove something is maybe some points are collinear or some lines intersect. Let's say on a circle, or some line is tangent to a circle. Usually those are the hardest ones. If you just need to show that two parts have equal area, usually it's not hard. But please have a go before. So if you haven't solved it, please try harder. It's not that hard. You just need to use all the information. So for example, here the question says it is a cyclic quadrilateral. So cyclic quadrilateral means the angles. If you join their diagonals, the angles are the same. And one more information is that they are perpendicular. So most of the information is about the angles. So please try to attack this problem from the angle perspective. Maybe somehow make use of the angle. Well, if you want to do something about the area and you know many things about the angles, I hope you know what to do. So if you please try, okay, I think you can crack it, and then you can compare with my solution below. So let me explain the hints which I just told you. Cyclic quadrilateral and the perpendiculars and the diagonals are perpendicular. So first of all, we know that this is perpendicular, and we also know that these angles are equal. So let me call this x, and then because this is cyclic quadrilateral, this is also x, and then this you don't have to call it. Let's just leave it as 90 minus x. Okay, let's call this y, and then this will also be y, and then you don't have to name the others, these angles, because this is 90 minus x, 90 minus y, 90 minus y. Okay, so always keep your variables minimum. So yeah, and we want to prove that CAE has the same area as CAEF. Okay, but let's just calculate the area of CAED. So here I join some lines. Okay, of course this is the radius. This is radius R. Okay, and then you can see that the area of triangle CAD, right, would be half of r square sine CAD, right? Half BC sine A, sine angle A, right? The area formula. But you know this is a center, so that tells you that angle CAD is just twice of angle CFD. Okay, CFD, I call it 90 minus y. So twice of that, that would be 180 minus 2y. Okay, but you know sine 180 minus something is just sine of that. Okay. Similarly, you can find out the area of DAE is half r square sine DAE. I should have an angle here, angle sine. DAE would be twice of DFE, right? DAE is twice of DFE because this is a center. So that would be, again, so this is XE, so twice of that, so 2XE. Okay. Now I hope you I think you can complete, you can see where my solution is going. So later I can calculate the angle of, I can calculate the area of triangle CAF and then triangle of FAE, and you can see, you can try, okay, and you will see that it boils down to the same thing. So I'll just quickly say that I'll just skip a lot of steps. So I'll just tell you that FAC turns out to have r square sine this angle, but this angle is twice of this one, twice of 90 minus XE, so 180 minus 2x, so that means sine x, and then area of EAF will be sine EAF, which is twice of ECF. ECF, I call it y, so 2y, and as you can see, so the sum of these is equal to the sum of these, and that is what we want to prove. So that is the solution. That is my solution. Yeah, so as if you look back, let's say you didn't crack it, let's say. So if you look back, if you reflect, you can see that I just made use of the information the question gives me, right? Perpendicular degree 90 degree, secant quadrilateral, also about the angles, and so that hints, that is a clue that you should attack this problem from the angle direction, which is sine something, right? The formula involve angle. Anyway, so let's give this a difficulty score. I think this difficulty will be about is this a hard Amy? Yeah, maybe at the level. Actually no. Let's just say 12.9. So maybe not a hard Amy question. And the character will be Sakura. cute. Thank you for watching.